Hey guys, this is Adrienne Groll and this is my teaching presentation on APIs. API stands for Application Programming Interface. It is a set of routines, protocols, and tools for building software applications. Basically, an API specifies how software components should interact. They're used when programming graphical user interface components. A good API makes it easier to develop a program by providing all the building blocks. A programmer then puts the blocks together. As a real-world example, think about the electricity supply in your house. If you want to use an appliance in your house, you simply plug it into a plug socket and it works. You don't try to wire it directly into the power supply. To do so would be really inefficient, and if you're not an electrician, difficult and dangerous to attempt. In the same way, if you want to say, program some 3D graphics, it's a lot easier to do it using an API written in a higher level language such as JavaScript or Python, rather than try to directly write low-level code that directly controls the computer's GPU or other graphics functions. An API will not give you all the program's information or code, because what would stop you from replicating the entire code base? Instead, an API provides you with data that its programmers have made available to outside users. Even so, you should know the language and ask the right questions in order to do anything with this data. They consist of three parts: the user, which is the person who makes a request, the client, which is the computer that sends the request to the server, and the server, the computer that responds to the request. Someone will build the server first since it acquires and holds the data. Once the server is running, programmers publish documentation including the endpoints where specific data can be found. This documentation tells outside programmers the structure of the data on the server. Then, the outside user can search the data on the server, build a program that runs searches on database, and transform that information into a different usable format. There are many different APIs for operating systems, applications, or websites. Windows, for example, has many API sets that are used by system hardware and applications. When you copy and paste text from one application to another, it is an API that allows that to work. Most operating environments, such as Microsoft Windows, provide APIs allowing programmers to write applications consistent with the operating environment. Today, APIs are also specified by websites. For example, Amazon or eBay APIs allow developers to use the existing retail infrastructure to create specialized web stores. Third-party software developers also use web APIs to create software solutions for end users. Programmable Web, a site that tracks more than 15,500 APIs, lists Google Maps, Twitter, YouTube, Flickr, and Amazon product advertising as some of the most popular APIs. Google Map API lets developers embed Google Maps on web pages using JavaScript or Flash interface. YouTube APIs lets developers integrate YouTube videos and functionality into website or applications. Flickr API, used by developers to access the Flick photo sharing community data. Twitter API offer two different APIs. REST API allows developers to access core Twitter data. Search API provides methods for developers to interact with Twitter search and trends data. Amazon Product Advertising API gives developers access to Amazon's product selection and discovery functionality to advertise Amazon's products to monetize a website. These days, APIs are especially important because they dictate how developers can create new apps that tap into big web services. For instance, social networks like Facebook or Pinterest, or utilities like Google Maps or Dropbox. The developer of a game app can use Dropbox API to let users store their saved games in the Dropbox cloud, instead of working out some other cloud storage option from scratch. In one sense, then, APIs are great time savers. They also offer user convenience in many cases. Facebook users undoubtedly appreciate the ability to sign into many apps and websites using their Facebook ID, a feature that relies upon Facebook APIs to work. Though, viewed more broadly, APIs make possible a sprawling array of web service mashups, in which developers use mix and match APIs from the likes of Google, Facebook, or Twitter to create entirely new apps and services. In many ways, the widespread availability of APIs for major services is what's made the modern web experience possible. For instance, when you search for nearby restaurants in Yelp app for Android, it will plot their locations in Google Maps instead of creating its own map. Via the Google Map API, the Yelp app passes the information it wants plotted, like the restaurant address, say, along with the Yelp star rating and more, to an internal Google Map function that then returns a map object with restaurant pins in it and proper locations, which Yelp can then display inside its app. On iOS, Yelp taps Apple's Maps API for the same purpose. We see APIs like this all the time. On many web pages, you can see the icons to share articles or pictures. On Facebook, Google+, Twitter, LinkedIn, Reddit, or YouTube, to name a few. These are just links that call on the APIs associated with each of those services to allow users to tweet or post about an article without leaving the site itself. A great example to discuss this is comment systems. They run by a service system. Disqus, Discourse, Livefire, and even Comments are great services. They use the service to accept user comments, and then they display them right on your website without your intervention. Okay, so an API is how two computers talk to each other. The server has the data and sets the language, while the client uses the language to ask for information from the server. Servers don't send data without a client requesting data, but developers have found some ways around this. APIs can do anything. Well, sort of. The language of and syntax of APIs severely limits their abilities. There are 4 types of actions an API can take. When you combine the endpoints with these actions, you can search or update any available information over an API. You'll need to check the API documentation to find out how to code these actions, as they're all different. Now, GET requests data from a server. It can be status or specifics. POST sends changes from the client to the server. Think of this as adding information to the server, like making a new entry. PUT revises or adds to existing information. Delete, it deletes existing information. Now, there are so many things we could talk about in regards to APIs. So let's look at SOAP versus REST APIs. For the most part, when it comes to APIs for web services, developers tend toward a RESTful architecture, unless the SOAP path is clearly a better choice. Say, for an enterprise app that's backed by more resources, it needs super tight security and has more requirements. SOAP is like using an envelope. It's extra overhead, it has more bandwidth required, more work on both ends, like sealing it and opening it. REST is like a postcard. It's lighter weight, can be cached, and it's easier to update. A good API will have clear and concise commands that a programmer can use and reuse, so they don't have to rebuild everything over again. There is no need to completely rebuild forms, commands, and scroll bars. All of these actions are accessible with APIs and can be brought into our programs. It ensures the consistent feel and look among the applications, but still allows for unique functionality. Google Maps has an extensive API with many different features. You can use it to build maps, geolocate tweets, search for local schools, and even measure elevation or distance. The API has a lot of documentation with several examples. Depending on what you're trying to do, you can find code snippets to help you achieve your goal. To be able to use APIs on our own sites, we need to use the certain API that the site provides. The Map JavaScript API lets you customize maps with your own content and imagery for display. On web pages and mobile devices, this API features 4 basic map types: a road map, satellite, hybrid, and terrain, which you can modify using layers and styles, controls and events, and various services and libraries. The easiest way to start learning about Maps JavaScript API is to see a simple example. This following web page here displays a map centered on Sydney, New South Wales, Australia. Even in this simple example, there are a few things to note. First, it is declared here as HTML5 using the doc type HTML declaration. We create a div element here, map, to hold the map. We define a JavaScript function which creates the map in the div. We load the map's JavaScript API using the scripts tag. The URL contained in the script tag is the location of the JavaScript file that loads all the symbols and definitions you need for using the Maps JavaScript API. This script tag is required. The async attribute here lets the browser render the rest of your website while the Maps JavaScript API loads. When the API is ready, it will call the function specified using the callback parameter. The key parameter contains the application's API key. Customers may either use an API key or a valid client ID when loading the API. Now, something important to talk about here is all Map JavaScript API requests must include an API key. They no longer support keyless access. And this is the case with many things. You must enable billing on each of your projects for these things as well. And that's all I have for talking about APIs. Thanks for watching.